We are taking indefinite integrals, R.D. Sharma solution class 12th, chapter 19, exercise is 19.23. Now we have 1 by 1 minus sin x plus cos x. So you know how to convert this sin x and then cos x. So just see the denominator first. Since we have already introduced the formulas, I am writing the formula directly. Sin x will be 2 tan x by 2, 1 plus tan square x by 2. What will be cos x? Cos x will be 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Now what we'll do here is we'll take the LCM. And since we have 1 plus tan square x by 2 in two terms, we'll write this 1 plus tan square x by 2. I'm writing this tan square x by 2 as t square, just for doing it in a short way. So 1 plus t square 1 plus tan square x by 2 will come here, minus 2 tan x by 2 plus 1 minus tan square x by 2. So this gets cancelled, 1 and 1 will become 2, and this is 2 minus 2t. Okay, this is the denominator part, that is 2 minus 2t divided by 1 plus tan square x by 2. Now since 1 is already in the numerator, this 1 plus tan square x by 2 will go up and it will form as sec square x by 2. 1 plus tan square x by 2, I have denoted t just as tan x by 2 right now. So it will be sec square x by 2 which goes up. So we have sec square x by 2 dx divided by, what do we get? 2 minus 2t. So you can just take 2 outside, and what is remaining inside? It is 1 minus tan x by 2. Now dx are already there in the numerator. So let's take t equals to tan x by 2, that is the assumption we are taking. Dt by dx will give you sec square x by 2. And don't forget to differentiate x by 2 so that you can have a half here in front. And then dx goes on the right. So this equation will form in this way. Half is already there in front of integration. And for sec square x by 2 dx, it will be 2 dt, as you see here also. I told you the explanation why it is 2 dt, because of the sec square x by 2 dx. So 2 dt, 2 already we have taken outside, dt here, 1 minus tan x by 2, tan x by 2 was taken as t. So 1 minus tan x by 2 t you can write. But here is a problem. One mistake I committed, I need to rectify my assumption. You know why? I could have just edited this part and gave you the actual answer. But you need to know what are the problems and how to survive those problems. Now if you take t equals to 1 minus tan x by 2, you will see what is the benefits. What are the benefits? So dt by dx will be, 1 will be 0, negative half sec square x by 2, negative 2 will go on the left, so negative 2 dt. Now this sec square x by 2 dx, which was previously 2 dt, has just transformed to negative 2 dt. That is the only thing changed here. If you take 1 minus tan x by 2 instead of tan x by 2 as t. Now this sec square x by 2 dx, negative 2 dt, negative 2 we have taken outside, it is dt. Now I tried to do this, but I stopped in between just to show you what is the problems we face. Now when we take 1 minus tan x by 2, it is simply t, and dt by t has a direct integration which is log, which is ln, log base e, modulus of t, 2 gets cancelled, you have negative outside. So minus log, what was t? Remember, it was changed to 1 minus tan x by 2. So 1 minus tan x by 2 plus constant of integration. As I indicated you earlier, log is log base e. You can just write it as ln as well. Okay, this is the result which I wanted to highlight, because you have to write this in this way exactly. Now this question is also similar to this question, the previous question. And there are certain questions of the same sort. And it's better that I explain you one or two of it which have more importance than the others. I'm not saying there is no importance of this question also. This may come also. But if you try the hard one or try the popular one, you will always be able to solve the easier one. That's what my thoughts are. So this question is almost similar to the previous two questions we have seen, but I am going to solve this, and the criteria remains the same. The process remains the same. I am taking the denominator right now. So this will be 13 plus 3. In place of cos x, replace it by the tan x by 2 conversion. I am just writing tan x by 2 as t just to make it easier for you to understand. It will be clearer also and easily understandable also. So I'm writing cos x as 1 minus tan square x by 2 divided by 1 plus tan square x by 2 plus 4 sin x can be written as 2 tan x by 2 divided by 1 plus tan square x by 2. So let me write it as 2 tan x by 2, 1 plus tan square x by 2. So let's take the LCM now. 13 into 1 plus tan square x by 2 plus 3 1 minus tan square x by 2 plus 4 2s are 8t and divided by 1 plus tan square x by 2. So this is 1 plus tan square x by 2, and please remember this was just the denominator. It was already having 1 on the up, that is on the upstairs part. So this 1 plus tan square x by 2 will go up. Now let's solve this one. 13 I'm multiplying its sign. 13 plus 13t square, 3 minus 3t square and 8t. So what do we get? 13t square plus 8t, or rather 13t square minus 3t square will give you 10t square. 8t is already there is no other t term, and 13 plus 3 will give you what? It will be 16. Now this 1 plus tan square x by 2 which was in the denominator will go up as 1 was already there. So 1 plus tan square x by 2 is sec square x by 2, and this will go in the numerator. So when we are actually integrating it, we'll start with this sec square x by 2 in the numerator. This is 1 plus tan square x by 2. Let's write it here, sec square x by 2, and this we'll write it here 10. Now let us take this t as tan x by 2 here to show you what exactly has come. So 10 tan square x by 2 plus 8 tan x by 2 plus 16, and dx is already there. Now are we ready to do this? Because previous question and previous question and few questions we have already done like this, completed like this. Now let us take t equals to tan x by 2, dt equals to sec square x by 2, dx half is already there because x by 2 has to be differentiated also. So 2 will go on the left. So this whole numerator can be replaced or can be written as 2 dt, 2 I am taking outside the integration sign, and this will be 10 t square plus 8t plus 16. As we see 2 in the numerator, we can do a simple simplification. We can take 2 common from 8t square. If I take 2 common from this, it will be 5t square 4t plus 8 in the denominator. This 2 we have taken out, and when this 2 taken out, 2 is already in the numerator, so this gets cancelled. So you are getting rid of 2 and 2. You don't have any constant right now. So 5t square plus 4t plus 8, which is in the denominator, this can be converted into a perfect square. So how are we going to do this as a perfect square? Let's discuss it again, because you know already how to do this. First of all, we cannot have anything in front of t square, so I am taking 5 outside. So please remember, whenever I am taking 5 outside or any term, any constant outside, it will always come in the denominator of the actual term. So I am taking 5. Whenever you take 5, you don't know what will come inside. Divide everything by 5. So t square plus 4t by 5 plus 8 by 5. In order to make it as a perfect square, take the coefficient of t, which is 4 by 5. Divide it by 2, you will get 2 by 5. Square it and add it and subtract it. So plus 2 by 5 whole square and minus 2 by 5 whole square. So what do we get? A square plus b square plus 2ab. T square plus 2 by 5 whole square plus 4t by 5 is a square plus b square plus 2ab. So it is 2t plus 2 by 5 whole square. Now the other term which is remaining is 8 by 5 minus 2 by 5 whole square. So 8 by 5 minus 2 is a 4 by 25. So it will be, if you take 5 in the LCM, you will get 40 minus 4. 40 minus 4 is 36. 36 by 25. So 36 by 25 can be written as 6 by 5 whole square. So we have got a perfect square here. 6 by 5 whole square you can write. Now this is a perfect square. So the integration has become something like this. There is nothing outside except 5. As I told you, 5 was already taken outside. So t plus 2 by 5 whole square plus 6 by 5 whole square. Now this is just integration of dx by x square plus a square. This is 1 by a tan inverse x by a. It's not 2a, it's 1 by a tan inverse x by a. What is x here? T plus 2 by 5. What is a here? 6 by 5. So let's write it here. 1 by 6 by 5, that is 1 by a tan inverse x by a. T plus 2 by 5, which is x. 6 by 5 is a. And this will 6 by 5 will become 5 by 6 when it will go up. 5 was already there outside, remember. So 5 is, if it is there, So this 5 gets cancelled here, and we have 5 was in the denominator. Remember 5 was not upstairs, it was downstairs. That is why we have cancelled 5. So 1 by 6 tan inverse 5t plus 2 by 5, 6 by 5. 5 gets cancelled. You have 5t plus 2 by 6. What is t? It was tan x by 2. So 5 tan x by 2 plus 2 divided by 6. And this is inside the bracket plus constant of integration. That's your final result. So this is how it has to be done, and you need to follow all these steps, not exactly like this, in the way the examiner understand what you wanted to present. Now this is a very general question, because we have done a question like this, 2-3 questions where we have some constant also added to the denominator. So I will just show you some other questions. Cos x minus sin x is also there. There is another question which is coming up, which is cos x plus sin x. And there are certain questions which follow the same scheme. So understand one question and try to implement those instructions in the other questions. So let me show you here. 1 by sin x plus cos x. I think this plus will be easier for you. So I am deciding that we will do this 1 by cos x minus sin x in order to better understand the previous question, which is simply 1 by sin x plus cos x. So the same scheme is going to be followed. Please remember. And there are various students, they complain that you always leave the important questions. But the thing is, there are so many questions which are repeated. So I always try to take those questions which needs more effort, so that you understand it better. Those who are requiring less effort can be solved by you, because I am quite confident on your IQ and your logic. We have cos x 1 minus tan square x by 2 by 1 plus tan square x by 2. I am just writing t as tan square x, t as tan x by 2. Just to show you in easier way how to simplify this. Minus sin x, in place of sin x I am writing 2 tan x by 2 divided by 1 plus tan square x by 2. So we will take this 1 plus tan square x by 2 as the LCM. So 1 minus tan square x by 2 minus 2 tan x by 2 has come in the numerator. But this is the denominator. I am saying 1 is already there upstairs. This is just we are dealing with the denominator. So we will try to resolve this, because 1 plus tan square x by 2 will ultimately go to the numerator, because this was just the denominator, 1 divided by this denominator. So 1 plus tan square x by 2 will go up, and 1 plus tan square x by 2 is simply sec square x by 2, that relation we have been using in this whole exercise. So we'll write like this: 1 plus tan square x by 2, that can be written as sec square x by 2. This is already done. Now we are just left with 1 minus tan square x by 2 minus 2 tan x by 2. Let me write it here. 1 minus tan square x by 2, which is I am writing in place of 1 minus t square minus 2t. So t we will take it as tan x by 2. And this will give you dt equals to sec square x by 2 dx, and half will also come, half 2 will go on the left hand side. So this sec square x by 2 dx can be replaced by 2 dt in this particular equation which I am pointing right now. 2, let's take it outside, dt divided by. Now 1 minus tan square x by 2 minus 2 tan x by 2, 1 minus t square minus 2t. So the whole thing which is left here is to make 1 minus tan square x by 2 minus 2 tan x by 2 as a perfect square, which is 1 minus t square minus 2t. So please remember, whenever we are making the perfect square, we don't need any negative sign in front of t square. We don't need any constant in front of t square. We have to get rid of that in any way. So minus t square minus 2t plus 1. Let's take negative outside. T square, all the signs will change. The only thing when we take negative outside is all the sign will change. It will be t square plus 2t minus 1. Now we have minus 1. This is not making a perfect square. So in order to make it a perfect square, take the coefficient of 2 divided by 2, you'll get a 1, add 1 and subtract 1. So I'm adding 1 and subtracting 1. Now this t square plus 2t plus 1, these three terms will form t plus 1 whole square. It's simply a plus b whole square. A square plus b square plus 2ab, a is t and b is 1. And this minus 1 will become minus 2. But we have to make it as a perfect square. So under root 2 whole square, you can just write like this. Now since it is negative outside, you can just replace these two terms, or you can swap these two terms with the sign, and this will form as, this is dt divided by, now let me write it here, root 2 whole square. I am writing it first because t plus 1 whole square has just become negative. So what is the formula we got? We got dx by a square minus x square, and you already know how to implement it or how to write this in the integrable form. So 1 by 2a, 1 by 2 is already there. What is 2a? A is root 2 here. So 1 by 2 root 2. 1 by 2a log modulus, log is ln only because log base e we are talking about. Modulus of whichever is there, the numerator will become a plus x and the denominator will form a minus x plus constant of integration. Please remember this has to be kept in the modulus sign because it is inside the log. Now ln is log base e, a plus x. What is a here? It's root 2. I'm writing root 2 here. The numerator has to be added, so plus. Now this t was what? T was tan x by 2. If you remember, t plus 1. So you can just write it as tan x by 2. Tan x by 2 plus 1. Root 2 minus tan x by 2 minus 1, because tan x by 2 plus 1 is t. When you multiply it by negative, it will be all negative. So negative tan x by 2 negative 1 plus constant of integration. This whole is the answer, but there is only one thing, 2 gets cancelled. So 1 by root 2 ln modulus of what content is inside is your answer. Okay, this is the way you are going to do this, and this is the same way 1 by sin x plus cos x will be done. So let me just show you how to do this. If you have any kind of problem, just let me know. We will solve it again. But it has a very much strong affinity with the previous question. Now this 5 minus 4 cos x have already been dealt in the previous first and second question. One was having cos, one was having sin in the same form. So I'm just showing you the result. 1 by 2 plus sin x plus cos x. So we have done this question like this. You just have to replace sin x and cos x in terms of tan x by 2, and this will be the result. Now 1 by sin x plus root 3 cos x. Now there is not much difference in the previous question of sin x minus cos x and sin x plus cos x we have seen. But we will do this because it has a root 3 somewhere in between. Till then, thank you so much.